My name's Aparna Sinha. I work at Google. I lead the product team for Kubernetes. And I'm really excited to talk to you today about a platform for serverless, a platform approach, in fact, an open platform approach. I think it's interesting that the previous talk talked about some of the challenges that are more platform challenges. How do you do authentication? How do you do monitoring? How do you do testing? I think some of those problems will be solved by taking more of a platform approach to serverless. So I'm excited to share that with you and get your view as well. So most of you, I think, in the room said that you are familiar with serverless. Can we do a show of hands again? How many of you are familiar with serverless? Yeah, most of you. Typically, when people think of serverless, they think of functions, snippets of codes that are triggered by some event, and it runs and then just uses the amount of capacity that it needs. At Google, we have a little bit more expansive definition of serverless. And so you might be thinking, what does that mean? Does that mean that Google's new data center has no servers? It's kind of like, looks like an empty garage. No, this is not what a Google data center looks like. You might be surprised, though, to realize that most of us at Google, most developers, never interact with a server. We write applications that run at a global scale automatically. We just write the applications, we put them into production, and they actually run at a global scale. They scale as needed with the demands of the application, with the demands of the users. But we never actually touch a server. How many of you here like to, install the operating system and upgrade the operating system and take care of the load balancing and take care of the networking? Show of hands? Well, actually, I think some of us do, and I do, but not on a regular basis and not for a system at scale. It's kind of interesting to do those things once in a while to understand how they work. But the environment that most developers want to work in, all of that is handled for them because ultimately the thing that you want to focus on is writing the application. So a picture of an actual Google data center. This is one of our newer Google data centers. I think it's based in Georgia. It's a very nice building, and there's actually thousands and thousands of servers inside Google data centers. So even though developers like myself and others at Google don't interact with any of the servers, there's actually lots of servers. And so how do we do this? And it's actually quite beautiful looking. Just wanted to show you it's not like an ugly garage. The key, I think, is that while there are thousands and thousands and thousands of servers, there's not actually a lot of people. There's not a lot of people involved in managing those servers. So a lot of the management of the servers, actually most of it, is automated. Not only are developers not doing it, but there's actually not that many operators working on managing the servers. And that's fundamentally the key to establishing a serverless platform, something that is automated and runs by itself. So you can write code and the infrastructure will take care of it. That's not how most application development is done. That's not how traditional application development works. In the enterprise, mostly there's a lot of overhead. You've got a developer that's trying to write an application, but they have to select the infrastructure. They have to, if they're going to use containerization, they're going to have to containerize their application. And there's a lot of setup of the operating system and figuring out the monitoring, like the previous speaker mentioned, figuring out the logging and where am I going to store things, and how am I going to set up the policies so that there's namespacing and the right functions and right organizations are running in the correct namespaces. Those are all things that are left to either the operations team or to the developer themselves or to a DevOps team. But really what it should be is that all of this overhead is handled. And in fact, we get to focus just on writing code. That's what it should look like. So we want to posit this new definition. This is the definition that we use at Google, that there's really three pieces of enabling a serverless environment. One is the operating model. The operating model for the underlying infrastructure needs to be zero ops. There's not much operations, it's automated. So you scale automatically. You also have the security pieces automatically. Secondly, the programming model. So currently the programming model is very much leading to the overhead that was on the previous slide. The reason that it leads to overhead is because the way we write applications today, they're very specific to the operating system or to the underlying capabilities of the operating system. And they're not, they're not generally, applications generally are not written in a way that they can scale across a distributed infrastructure. So functions, yes, functions, you can write snippets of code and they're specific and they're event-driven. But really, serverless should be beyond just functions. Why should it only be event-driven serverless, event-driven function code? Why not entire applications? If we write our applications in a different way that is fundamentally more scalable and decoupled from the infrastructure, then serverless can apply to all applications. And that's really the broader definition. Lastly, the billing model, it needs to be pay for use. So exactly what you use in terms of the infrastructure, that's what should be metered, and that's what should be billed. This is the more expansive, broader definition that we use internally. And when you use this definition, it's not just about the compute. Just providing serverless compute capability isn't sufficient. Actually, in order to allow your developers to build serverless applications, it needs to also extend to a number of services. So the monitoring and logging, that should be available as a service. The security pieces should be available. The data storage and the databases should be available as a service so that a developer can essentially just focus on their code and consume all of these services and run on infrastructure that's serverless. So the benefits of this, I think, are obvious. It accelerates time to market, allows developers to focus on what they need to focus on. There's no server management. And lastly, you pay for only the usage. So the benefits are obvious. Having defined serverless in this way, the question is, how does Kubernetes fit into this picture? How many of you here are familiar with what Kubernetes is? Wow. That's a very large chunk of people as well. Okay, great. So I'm going to go into how Kubernetes can be a platform for serverless. This is really still an emerging and growing space, but I'm going to show you some of the work that's happening in Kubernetes that allows it to be a building block for running serverless applications using the definition the broader definition that we just discussed. So fundamentally, at least at Google, it is about decoupling the applications from the underlying infrastructure, writing the applications in a way that they're self-contained and they are scalable across distributed infrastructure, and then automating the management of the underlying infrastructure. Those are the two pieces. I'm going to talk a lot more about automating the underlying management. So what it boils down to, and this is the secret about serverless, what it boils down to is containerizing the application so that it is independent from the underlying operating system and the underlying infrastructure, and then automating the management of the infrastructure, and lastly, adding in granular billing or granular metering. This is what we do at a high level. Talking about how do we do the automation of the infrastructure, that's where Kubernetes comes in. It is fundamentally many different things. Kubernetes is a platform at the fundamental level. And there are many definitions and many things that it does, but I think what is important for serverless is these 5 things. So first of all, providing infrastructure as a service. Secondly, automating management. And then thirdly, being extensible so that companies can create additional APIs that extend the Kubernetes API for things like functions or things like applications or custom resources that a developer team might want to consume. I'll talk through each of these. So container infrastructure as a service. You think about a platform that's going to isolate applications from the infrastructure. That platform needs to understand the infrastructure and actually automate it. So there's a number of primitives in Kubernetes that understand all of that under the hood. It has the concept of instances and VMs or groups or nodes. It has the concept of understanding networking and understanding load balancing and storage volumes, but it isolates you and I from all of that. Kubernetes as a system takes care of those pieces. And it actually is brilliant in that it takes care of those pieces regardless of the type of environment. So it does so in your on-premise data center. It can also do so in the cloud, in multiple clouds. That's one of the most beautiful things about it. So it has all of those infrastructure concepts. You and I don't need to know about them. Secondly, it has a set of primitives that are more application specific. And those are the more important ones here from a developer perspective. The main primitives there, there's the primitive of a pod or a container. And then there's the concept of a service. A service is basically anything that has a network endpoint. Built upon these primitives are several other primitives, things like deployments. Deployment is something that you deploy code to your environment. And a number of other primitives that over the course of the last 3 years we've added that are typical for an application. So the concept of daemon sets, which is you want one pod per node. You want one of that particular application instance running, in each of your instance groups. And then the concept of a batch workload, or something that runs a job. These are all primitives that we found useful in managing and running applications. And so the Kubernetes API has grown to add these primitives that are application-oriented. In fact, one of the most recent ones that is being currently discussed in the community is the concept of an application. So the application is actually a combination of many of these things. It's a number of different services, some deployments, and some of the networking and other resources. This is kind of the guts of the system, again, in Kubernetes. But the fundamental point is that it's a very composable system. You can take these primitives, build your application out of them, or actually you can create your own primitives. So that's the base. Secondly, it's a platform for automation. So there's the fundamental concept of a control loop, which is a feedback loop, which basically says that you want the state to be X, and the control loop and the system works to make sure that that X is actually achieved. A basic example of this is replica set, which basically says that I want 3 or I want X number of replicas of my application running, and Kubernetes will make sure that that happens. And not only will it make sure that that happens, it'll take care of all of the underlying management of the machines and the networking and the IP address and storage that the application needs to connect to and how the application gets discovered. It takes care of all of those pieces underneath. And this concept of a controller allows us to create lots of different types of automation. Autoscaling is a result of this. So the system will autoscale, and it'll not only autoscale, it'll autoscale based on application metrics. So it'll autoscale, say, based on the length of a queue. It'll autoscale based on the latency of that the application is experiencing. Again, a very, very rich platform for automating management. And then I think the biggest piece is the extensibility. So the Kubernetes API is of a certain type, and you're seeing many of the types. I showed you service, I showed you replica set, but it's actually fundamentally extensible. So you can write custom resources. You as a user or you as a team in a company can write custom resources, and it'll work the same way. You can write custom controllers. It'll work exactly the same way. So for example, one of the extensions of Kubernetes is to run batch jobs using Spark. And what we've done there is we've written a custom controller and a custom resource that allows Kubernetes to understand what Spark is. And it automatically deploys Spark on a Kubernetes cluster, and then you can essentially talk to the Kubernetes API as if you were talking to a Spark system. You can tell it, run this job, and it'll automatically take care of the underlying primitives, services, pods, etc., and just run Spark for you. That's the power of the extensibility. And I'm going to show you how we use that extensibility to run something like functions. But again, it's a very broad platform and a very broad mechanism, not just for functions, but for running any kind of application. So let's switch to the demo and talk about functions. Again, functions are just small snippets of codes triggered by some sort of event. And you don't want to have to know even all of the underlying concepts of Kubernetes in order to do that as a developer, right? So there are a number of different frameworks that are, I think, 17 different frameworks currently that, that have developed in the Kubernetes ecosystem to run functions on top of Kubernetes. And this is just going to be one of them that I will show. Make this bigger. Okay, so the first thing we do is we create a cluster, and we're going to create this cluster in Google Kubernetes Engine. It's very simple. Click on Create Cluster, and we've pre-created this cluster called Geek Demo. As we look at it, it basically is a Kubernetes cluster. It has a master and has some number of nodes, and the master endpoint has this IP address 104, and we're going to connect to it from our local environment. So we go ahead and now you can see that we are connected to this cluster and through this endpoint. And we'll create a namespace where we will install a framework. So this is an extension. Now we're taking the Kubernetes API, we are extending it so that it understands the concept of triggers and it understands the concept of functions. And then we're going to use that extension to actually run a function. So you add this framework, add this extension to Kubernetes, and then you can basically use that platform, not just for applications and not just for stateful services, but you can use it for functions. Same platform, all of the policies, all of the other aspects of the platform are still there and usable. So we created a namespace. This particular framework is called Kubeless. It's one of the 14 frameworks for functions on Kubernetes. And what it does is, so what we did is we used kubectl, our command line, and we took this code for Kubeless from GitHub. And what it does is it really creates these custom resource definitions, these 3 custom resource definitions. So functions, HTTP triggers, cron job triggers. There are many other types of triggers that you can define in the system, and there are many other types of custom resources that you can create. These are the 3 that we're going to use or we're going to talk about here. And so, get functions. Now you can do something like kubectl get functions because it understands the concept. Kubernetes understands the concept. There's no functions right now. But just to show you what we've done is we've extended the Kubernetes API. So let's look at what is the Kubernetes API. It has lots of things, like I mentioned, over time. Started with pods and services and replica sets, but over time understands jobs and understands many other things. So you can see it has apps. There's the concept of the set of APIs under apps. It has APIs for authentication, APIs for auto-scaling, for batch workloads. And then this is the one that we've added. We've added now this kubeless set of APIs. And what is that? So we see what are the custom resource definitions that have been created. And really, kubeless consists of these 3 custom resource definitions. So now the Kubernetes API actually understands what a function is, and when I use the commands associated with functions, it'll be able to do things like running a function. And underneath it, this definition will actually start a deployment. It'll start several services, and it'll start pods. And when the work of the function is done, it'll get rid of them. And in the middle, it'll auto-scale them. So underneath, this framework is using all of the primitives of services and deployments and auto-scaling. But for the user, all of that has been abstracted away and added as a extension to the Kubernetes API. So it looks native. I hope that makes sense. So now we're going to create a function. So we created this function that's just going to return hello world. And all we need to do is we can use kubeless function deploy. And what we need to specify is just where is the function. So it's a Python function, and it's in func.py, and what the runtime is. So it's Python 3.6 and what the handler is. And that's it. Now, we can go ahead and Kubernetes will deploy the function, and it automatically will provision the runtime that is needed. It'll all be inside a container, and it'll scale this and create the pods that are needed to run this function. And so here you see the function has been created, and then if we take a look at what has been done in Kubernetes, these 3 pods have been created, and there's an ingress controller and a default backend, and so on and so forth. Those are details that if you're a Kubernetes admin, you may want to see them, but if you're a developer, you didn't need to know about all of that. That was all handled underneath. So fundamentally, Kubernetes is a platform that's composable. You can build higher and higher abstractions on top of the existing capabilities. Many of those can be custom abstractions, and over time, as they become more standard, they get subsumed into the system. And so this is an example of how you'd run functions. I think that's the end of the demo. So we'll go back to my slides. And as I mentioned, this kubeless is one of 14 or 17 different ways, different frameworks that have evolved just around functions. So clearly there's a lot of interest in running functions on Kubernetes. And as I said, over time, some of these primitives like, how do you define events? And how do you run functions? Is there a common framework that everyone should use? I think that'll standardize and become, these are the ways of doing that on Kubernetes. But there's a very, very vast ecosystem, not only for functions, obviously, works on all aspects of the platform. So with that, I think the question is, okay, that's great. You can do functions on Kubernetes. You can do other things on Kubernetes. Why is it really unique? There are many systems that automate infrastructure. Why would I use Kubernetes for this? And I think the answer lies in a lot of the systems for serverless today are proprietary, and they involve lock-in. So you can only run your workloads. You can't run all of your workloads. You can only run your functions in that specific environment. And secondly, many of them are single purpose. So it's only for functions, and it's maybe only for certain frameworks or certain runtimes, not really general purpose. And it's only for functions. It's not for all kinds of applications. And that's, I think, fundamentally the difference between using something like Kubernetes, which is a portable cloud abstraction. It doesn't tie you to one infrastructure or one type of cloud. It doesn't tie you to one type of application. You can run any type of application. Some of the things that make Kubernetes portable, and most of you said that you're familiar with it, so some of the things that make it portable is the abstractions that we have for the network, for the volumes, the abstractions that we have for the different cloud providers, and the fact that it can be, it's very portable. It can run in your on-premise data center. It can run on your local laptop. So someone said, I think in the previous talk, that how do I actually run this function locally? Well, with a platform like Kubernetes, you can run the function locally, and you can run it anywhere. And then secondly, making the applications more portable, that comes from just the containerization. So now you're writing not just a function, but a whole application, and by containerizing it, the application becomes more portable. So essentially, why Kubernetes for serverless boils down to multi-workload platform that's flexible, that's composable. You can build new primitives on top of existing ones. It's portable, and it comes along with a lot of ecosystem tooling. So you don't need to set up the monitoring and logging separately. You don't need to worry about the policy automation and namespacing separately. You don't need to worry about how do I do testing? How do I do the testing of the function? Because there's a CI/CD methodology already baked into how you can run applications on Kubernetes. So that's the aspect of platform that comes along with it. So you set your permissions on your namespaces. You have your users in the platform, and that applies to all the functions and all the users that are using the functions, in addition to the applications on the system. So really much more holistic. And with this type of holistic paradigm, we can go from functions being a managed runtime environment that's single purpose, proprietary, locked in, source driven, to something that's flexible, something that's not just functions but also apps and containers, and that's multi-purpose and is portable based on open standards, and then is source and container driven. So that's it. Thank you.